model. For the selection starting with a model with a no independent variable. That's what I said again, y equals the mean of y. That's the starting point. And then you find out the highest significant f. But this slide says highest significant f, but sometimes this is the lowest p-value. Okay, sometimes the highest. So that's what you choose. Adjusted r square and so on. So, but what it means is highest, lowest, or highest, whatever. You just trying to, let's say we have a x1, x2, right, xk, then you try y equals b0 plus b1 x1, and then you can get a f statistics or the p-value or the adjusted r, whatever your criteria you use, you find out. And then you run the regression with the x2 only. And you do the regression with the x3 only, and so on. And then you do the regression with the xk only. And you can find the fp adjusted r for each of them, right? And then depend on the criteria, you will choose the best one. Okay, so from here you choose from the beginning y equals the mean of y. Now one step later, so you find out y equals b0 plus, let's say x2 has a highest f or highest p or highest adjusted r square. So x2 was selected. Now what are you gonna compare? Here what you're gonna compare is the y, right? And then what you're gonna compare here is the you have to try y equals b0 plus b2 x2 because this is already included. Now you try plus b1 x1 and also b3 x3 and so on. Right? And then you choose the best again. Let's say x5 is selected, and then you keep going on until you are not improving. So here there's a stopping rule. As long as the p-value is smaller than the predetermined value, you don't add, right? So this is for the selection. Once you got in, you will not be removed at all. It will stay forever. So sometimes what is this problem is sometimes actually x1 is better than x2, right? However, in that case is you will be selected. So x1 and x3 together will be better than x2 alone. Okay, that's the case. Okay, for example, x1 and x3 together, this will be better than x2, but they are high correlation. x1, so x2 is similar to the x1 plus x3. Together this is better than x2, but x2 has a high correlation with this. Then if we choose the first one, x2 is better than x1 alone, but x2 is better than x3 alone, then x2 will be selected, right? So x2 will be selected. Once x2 selected, x2 will not leave. x2 will stay the model. And next we're trying to find out x1 and x3. Since x2 is already there, x1 and x3 will not have a significant effect, right? Because x2 is there, because they are highly correlated. So x1 and x3 will not get a chance to get into this model at all. So we will end up with just x2 without x1 and x3. So if we dropped x2 and x1 and x3, that might be better model, but we lose that chance. So for the selection is just choosing, just keep adding, and certain criteria, the p-value or something like that, and you just stop. So you can use adjusted R, so you just keep adding new variable until adjusted R is not increasing at all, or you can keep adding until the p-value, certain p-value is not reached at all. So once it reached the p-value, so new variable doesn't have a small p-value, it's a high p-value, then you just stop the adding and you have to stop. So we will see some example in the R here. So that's the forward selection. Again, even though my slide said it's a significant F statistics or p-value, but you can use just the R or the p-value separately. Backward elimination is totally opposite. It's starting with a full model. So model containing all independent variables. It contains, we put everything in it. Of course, I don't want this big model. And then you just eliminate one element by one element. You just drop to the least significant F or highest p-value, right? And then you can try the element of one variable by one variable, and then you can also choose the highest adjusted R square. You can just try one by one, and then which one should I remove? Then we can get a higher adjusted R square. So again, this criteria can be different. But anyway, we start with a full model, and then you just eliminate one by one. Okay, until the certain criteria met. So you can use adjusted R square or the p-value. So I will demonstrate how to use it in the R. So you can do everything in Excel, but if you want to do this Excel, then you have to run the regression all by yourself. Actually, here, if you have like a 10 X values, right? If the K is 10, and the first variable selection, you have to run the 10 regression, and then choose one variable. Which one should we add? And then second variable, when you add, then you have to run the again the 9 possible regression, and then you choose the second variable and so on. So you have to run the regression so many times by yourself. Still, you can do that with Excel, but the advantage of using this R function is this function, computer will do that regression by itself automatically, and they make a decision according to our criteria, and then it will give you the final answer. So backward elimination is starting from the full model and then get rid of the variable one by one by given criteria. Stepwise regression is a little bit different for the selection and backward selection. So this is starting from the same as the empty one, but when you add the new variable and we re-evaluate, and then we will do like a backward elimination, we will trying to find which one should we drop. If we find something to drop, and we're gonna drop, and then we're gonna look for what would be the new variable, and we find the best new variable, you add it. Once you add it, and then you're trying to find out which one should we drop. If there's nothing to drop, and then you're just looking for the new adding variable, and once you got a new added variable, and you're looking for which one should we drop. So you have to move the adding forward one step and backward one step, and forward one step and backward one step. Since we are using the forward backward alternatively, actually, so one variable may chosen as the next best one. However, maybe after the several steps, that variable can be dropped because of the other variable can be covered, or the example I used is previously x1, x3 is better than x2. X2 was selected, but after we choose x1, x3 together, if all of them are in the model, maybe we better drop off the x2, right? So x2 was selected at the beginning, but later it can be dropped. It's possible, and then also it's possible x2 come back because the later we can add some other variable. Maybe x2 has some kind of relationship with that. Because of that, maybe x2 bring the value. So for the scheduling for the selection, once it got in, it will never leave. But backward elimination, once it dropped it will never come back. However, the stepwise forward and backward together, is it possible selected variable can be dropped it, or the dropped variable can be selected the next step? That's possible. So our function, this is a both. The both means is forward and backward together. Again, the r square, adjusted r square or p value can be a criteria. All possible regression is like a crazy method. Without computer, you never want to do this. Yeah, using Excel, you don't want to do this with Excel. That's why there is a lot of company created the Excel add-ins, right? So you don't have to do the regression by yourself manually so many times. However, Excel only, you have to do it manually. You have to run like hundreds of the regression to do the all possible regression. So all possible combination regression is you just trying the all possible combination of independent variable. One variable, two variable, three variable, four variable, even two variable. There can be a lot of different two combinations, right? So if how fast it's growing up? So if you have a k independent variable, there is a 2 power to the k possible combination. If you have a 10 variable, 10 independent variable, there will be a more than 1,000 possible combination. So you have to run the all possible regression, 1,000 regression, and among them, you find the best one. That's why without computer, you don't want to do this by hand. I mean, even using Excel, pure Excel doesn't have that function. Excel, you can run the one regression, but you don't want to run like 1,000 regression. So again, this function, this is all possible function, will run. So this is a kind of has the longest runtime. Show you the result of the all possible combinations, and then if you look for the highest adjusted R, highest adjusted R, you can find it, and then you can find which model provide the highest adjusted R square. Then you can choose that model. Again, the reason why we use adjusted R is the adjusted R will penalize more variable. So we don't want to have like a 1,000 variable model, right? So we want to model as simple as possible. However, the prediction power as much as possible. So that's why we want to use adjusted R when we compare the two model, especially when the two model has a different number of variables.